All right, stats, here we are again. This is your Friday notes video here. As we know, we got sponsors in the house. Crystal Light Pure Energy, Noon Hydration Energy, Cliff Bar, Laura Bar, and our in-house class, Stuart the Minion, holding it down with now an official sponsor, the Knee Rover Knee Scooter. Hopefully you never have to be in, but if you do, Knee Rover. Intro question. So now we're on to chapter 10, and this is probability, and really like chapter 10 a lot. Chapter 10 and 12 are very similar to each other. We talk about probability in chapter 11, but it's an interesting take on that. It's kind of a essential limit there, big deal that we're going to use the rest of the year. 10 and 12, very similar. Now we're really into some interesting stuff here on out. All right, so you're a 72% free throw shooter and just got fouled on a three-point attempt with your team down by 1 and 1.2 seconds left to play. Oh boy, what is the probability you make at least 2 of the 3 and win the game? Folks, you need to define what you want. X is a made free throw. You want to know the probability you make 2 or more. First off, so we should probably write down probability of success. 0.72. That's what 72% means. Here's the chance you make all, probability you make all 3. 0.72 times 0.72 times 0.72. Or, this is a little quicker, 0.72 to the third. 0.72 to the third power, rounded to 3 decimals, is 0.373. All right, so here are all different distinct situations of making 2 out of 3. You could make it, miss it. You could make it, miss it, and in suspense, make it. You could miss it, make it. 3 different ways to make exactly 2 out of 3. Now, if you notice, in each of them, you're doing 0.72 times 0.72 times 0.28. So you're going to have 3 of those. So if you want, you can do 0.72 times 0.72 times 0.28. Oh, not 28. Uh-oh. We know probabilities can never be bigger than 1. So let's try that again. And you get 0.145. And if you multiply that by 3 immediately, you get 0.453. Now, it depends on rounding. You know, if you wrote, 145 down 3 times, then add them all up, you won't have, there won't be any issue rounding-wise. So 0.435 is the probability you make exactly 2. If I want to know the probability of making 2 or more, then I need to add those 2 probabilities together, and that is a 0.808 chance. Probability is 0.808, 81% chance, basically, of you winning that game. All right, so probability of A, P of A, that means the probability of event A occurring, okay? 1 minus probability of A is probability of A not occurring, also known as the complement. That's going to be very, very important for us, the complement. In fact, we're going to use it right now. Your favorite baseball player is currently batting .384. Wow. That means getting a hit 38.4% of the time. And is averaging 4 at-bats a game. Find the probability that this player gets at least 1 hit in his next game. At least 1 hit. So X is a hit. We want the probability that X is greater than or equal to 1. Which, just like before, the probability that X was greater than or equal to 2 was the probability that X is 2 plus the probability that X is 3. But here, man, the probability of getting at least 1 hit. It's probability to get 1 hit plus 2 plus 3 and then 4. This is going to make me write a lot because I could get a hit, not, hit, not, hit, not, hit, not, hit, or out. Out, hit, and that's only for that. My goodness, this would take way too long to do that. So in a lot of situations, when I want to know the probability that something occurs at least one time, then instead I can just do 1 minus the probability that it doesn't occur. If I know what's the probability that it won't occur at all, then I know what the probability that it will occur at least once is going to be. This is a prime example for figuring out the complement. So if the probability of a hit is 0.384, the probability of an out is 616. Why do I want to know that? Because if I want to know the probability that x is 0, because again, if I want the probability that x is greater than or equal to 1, I'm just going to do 1 minus the probability I get no hits. I want to be unsuccessful 4 straight times here. 0.616, 0.616, 0.616, 0.616, because it's an out, 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 0 for 4. Probability that I get 4 straight outs is 1 for 4. So probability I get at least 1 hit is 1 minus, almost put the answer there, 1 for 4. So the probability I get a hit is 0.856. We're going to use the complement a lot. All right. So we're going to do number 2 when we're back together. So back to a similar question to the intro example. You're an 88% free throw shooter, and to have the opportunity to shoot 3 free throws, what's the probability you make all 3? Again, always tell me what x is. X is a made free throw. I want the probability that x is exactly 3. The probability that you make it, you're successful, is 0.88. I just do 0.88 to the 3rd power because I'm going to drain 3 straights. That is 681. What's the probability you make at least one of the 3? Probability that x is greater than or equal to 1. The quickest way to do this would be 1 minus the probability that you miss all 3. So if the probability of a make is 0.88, probability of a miss is 0.12. 0.12 to the 3rd power is 002. Wow. This is a 99.8% chance that you'll make at least one of them. All right, so then on this last part here, what's the probability you make at least 2 of the 3? What's the probability you make at least 2 of the 3? Probability that x is 2. You make it, miss it. Make it, miss it, make it. Miss it, make it, make it. You got to have all the situations there, okay, of making exactly 2. Probability that you make 3, well, we already know that from part A there. The probability you make all 3 is 681. We don't need to find that again. So probability you make exactly 2, again, what I could do is I could take 0.88 times 0.88 times 0.12. That's 093, and I would triple it because I'm going to see that 3 times. I see 8812, or 88, 88, 12, 3 times. So 0.279 is the probability they make exactly 2 of the 3. Add that to the probability you make all 3. Add those together, and that is 0.960, a 96% chance you make 2 of the 3. Wow. Very good. All right. So on this next page is pretty cool. Very interesting stat now in baseball especially. We're going to do number 4 together though in class, and we will actually do number 5 together in class. So chapter 10 in your book is actually very simple, almost too easy. So we're going to do these apply your knowledge questions together, preparing for the GMATs. So to get into a business school. Many settings, real probabilities are just basic facts about percentages. That is the case here. A company that offers courses to prepare students for the GMAT test has the following information about its customers. 20% are currently undergraduates in business. Makes sense if you major in business. You probably want to get your MBA, Masters of Business Administration. 15% are current undergraduate students in other fields of study. All right. 60% are college grads who are currently employed, and 5% are college grads who are not employed. Notice how they all add up to 100. What percent of customers are currently undergraduates? are currently undergraduates. It's 20 plus 15, 35%. I just simply added them together. The addition property. 20% are undergraduate students in business, and 15% are undergraduate students in another field. What percent of customers are not undergraduate business students? So it's 100 minus 20. Just found the complement. 20% are undergraduate business students. 80% are not. All right, so let's keep doing these. 10-9. Overweight. Although the rules of probability are just basic facts about percentages or proportion, we need to be able to use the language of events and their probabilities. Choose an American adult at random. Define two events. A, the person is obese. B, the person is overweight but not obese. According to the National Center of American Stats, probability of A is 0.32 and the probability of B is 0.34. Explain why they're disjoint. That means there's no intersection because, again, it just says it right here. You're obese, you're overweight, but not obese. You literally have to be one or the other. Okay, so that's why there's just disjoint. There can be no intersection between obese and overweight, but not obese. Look what B literally says that A can't happen. Say in plain language the event A or B, what it is, and what is the probability of A or B. Probability of A or B is a situation where you pick someone that is either obese or overweight. Just add them up. C is the event that the person has a normal weight or less. What's probability of C? We just do 1 minus what we found in part B. All right. Languages in Canada. Canada has 2 official languages, English and French. Choose a Canadian at random and ask, what is your mother tongue? What is your mother? I believe it's the same page. This is the same question, right? Yes. All right. Okay. So, what is the what probability should replace the question mark? So you just need to do 1 minus the sum of all the others. 85 and 91. So 09 needs to go in there. What's the probability a Canadian's mother tongue is not English? 1 minus English. 3 out of 8. That's 0.375. Actually, what's the probability a Canadian's mother tongue is a language other than English or French? 1 minus 63 and 22 is going to be 1.5. You could also add up 06 and 09 to get 1.5. All right. Again, we will have a day where I finish these notes in class. Finite sample space, discrete. Okay, so we'll talk about that, discrete versus continuous. All right, so here your first digit, here's something that's discrete. First digit is either 1, 2, 3, 4, 5, 6, 7, 8, or 9. Your social security number isn't like, 1.5, 2.5, nope. This is very interesting, Benford's Law. We've talked about the book and then the movie Freakonomics. This is something sort of like that, where they can catch things that are false. Benford's Law here, very cool. I'll give you some more inside info to Benford's Law, but they can check to see if something is an illegitimate bank account, credit card. All right, just think about your social security number. Think about if you had a bank account, anything like that, credit card number. The probability that the first digits starts with a 1 versus a 2 versus a, if someone tried to cash a lot of, or try to use, something fraudulent, a lot of bank accounts that start with a 9, just a ton of them, you'd be like, something's false there. All right, so that's pretty interesting. Okay, a lot of people have social security numbers that begin with a 3. Bank account numbers that begin with a 1. So this is very, very interesting. We'll go more in detail how they found those numbers. All right. So let's talk here. Let's just finish these notes. Working out. Choose person aged 19 to 25 at random and ask in the past 7 days how many times did you go to an exercise or fitness center or work out. Actually, I read that wrong in the past. Or work out. So I wouldn't be counted as a 0 because I'd never go to fitness center. But in-house, N1s, home, basement, outside, working out. So verify that it's a legitimate discrete probability model. First off, you can't exercise 1.5 days. It's either 0 through 7. It's countable, no decimals. Why is it also a probability model? Because if you add these up, 73, 80, 88, 93, 97, 98, 100, all the probabilities add to 1. Describe the event x is less than 7 in words. That means you work out 6 or fewer days. You don't work out every single day of the week. You work out 6 or fewer days. What is the probability that x is less than 7? Now, again, I can write it as x is less than or equal to 6. Okay, because it's everything 6 or less, and that probability is just 1 minus the probability that you work out all 7 days, 0.98. Express the event worked out at least once in terms of x, and what's that probability? If you worked out in terms of x, so I do ask these questions a lot. What's the probability that x is greater than or equal to 1? Instead of adding up 6 numbers, I can do 1 minus the probability of 0. All right, go to a school with a nice rec center, not a rectangle. SIU Carbondale, great one there. When people get outside of high school and outside of practices and be involved in a lot of sports, sort of things can go south. So find a spot, find a good spot to go. Outside's always great. We want to keep being active post-high school. Random variable is a variable whose value is a numerical outcome of a random phenomenon. Probability distribution of a random variable x tells us what values x can take on and how to assign probabilities to those values. All right. We'll just go here for a few more minutes. Grades in a stats course. North Carolina State University posted grades distribution for its courses online. Students in Stats 101 in the fall of 07 when I started college. That was the grades on a 4.0 scale. Say in words, what is the meaning of x greater than or equal to 3? What's its probability? Greater than or equal to 3 means they got an A or B. What's the probability that a student got an A or a B? All right, and add up those probabilities. 0.68. Write the event. The student got a grade poorer than a C. A C is worth 2 points. So you can say what's the probability that they got less than a C, or you can say what's the probability that x is less than or equal to 1. Because if you're less than 2, what's the next one? 1 or less. So what's the probability a student got that undesirable grade of a D or an F? That probability is 0.2 plus 1.0. That's 1.2. All right, let's see what else do we have in here. We're actually going to stop there. Your goal the weekend of the 16th and 17th is definitely finish this homework if it's not done. Number 1 is a pie chart. You got a 5K, 10K, half marathon, full marathon, round to the nearest tenth of percent. So if you get something like 0.368, that's 36.8%. You get that. Make a stem plot for the midterm grades. Okay, what's the lowest score? 29. Then I believe it's followed by 45, ... You got a 90 and a few more in the 90s. That's a very easy one. All right. So this one is not due. I got rid of the due Friday part. Yeah, cool. You guys know it's due Wednesday the 20th. When I gave it to you, I said Wednesday the 20th. Going to be due Wednesday the 20th. All right. Oh, sorry. Number 2. You know how to do this by hand. There you go. Use those. Number 4, box plot, 5-number summary, min, max. Put them in order. 1.5 times IQR. Use it to mention any outliers. Make sure to write the interval. If it's like 12 to 68, write that. Or, we're talking about ACT scores, so it could be to 68. But you get that. And number 5, you got to tell me what x is. What's x? Give me a probability statement on E. In fact, I've given you the probability statement. You're using your z-table, so write exactly what your z-table tells me. 0.2168 or something. Don't round it. Write exactly what your z-table tells you. Top 10%, bottom 10% score. Don't round. Just write what your calculator says. Number 6, renowned school has a certain test. Same thing. What is X? It's a pretty interesting question. I wrote a few fun ones here. This is a fun one. Male heights. What percent of males is shorter than 5'6"? Give me a probability statement. Probability that X is blank. All right. 7 was fun. What we got here? 8. Linear regression equation for home runs hit. That's the predictor. And runs scored. So predict. You're just going to tell me what Y hat. Y hat is blank. Just round it to 2 decimals. Then find the residuals. Same formula. Y hat is 1.89x plus 479.34. Find Y hat for me. Find the residual, which is Y minus Y hat. Rounded 2 decimals. You don't have to say over, underperform. And if it's positive, they overperform. If it's negative, it's underperform. Just get the signs correct. Y minus Y hat. We talked about this one to be solidly middle class and asserts and community. I think it did a little better job here, making it more realistic. Rounded 2. You can round to 3 decimals if you want here. 2's fine, but 3's also good because we're talking about in thousands of dollars. Okay. Can show your work on E. And that's it. So start off the second quarter with a nice grade. Definitely make sure it's done the weekend of the 16th and 17th. You can do that. I'm going to finish up this note packet for your Monday notes. And you might have the next homework packet in your possession, so you can start on that. We will tie up Chapter 10. I'll give you a few extra good notes as well. And we'll finish that up. And then on Wednesday or Thursday, the 20th or 21st, you're going to have that Chapter 6, 8 in class assignments. So if you missed any notes, make sure to get those before then. This is Yak Math Videos signing out.